statistics can actually be divided into two branches, the descriptive statistics and the inferential statistics. Of these two branches of statistics, the statistical inference is the broader aspect of statistics. Now, in statistical inference, there's an important gray area in statistical inference that many times students, researchers find a little bit difficult to comprehend the concept, and that is statistical significance. Today, I'm going to talk to you about the concept of statistical significance. What does it mean? How do we measure statistical significance by which we can make sense out of our data sets or maybe data analysis? My name is Dr. Felix Ayodele Ile. Now, let's get right into it. Now, to start with, it's important to understand that at the beginning of every research, a researcher will always want to come up with a hypothesis. A hypothesis is an unproven claim that a researcher sets out to actually establish at the end of that particular research. Now, what will determine the validity of that claim is the difference that the researcher is able to establish between a particular group or another group, or maybe an existing concept and the new concept the researcher is bringing on board. Okay, so, and that takes us to the concept of statistical significance. The difference the researcher is able to establish, is it meaningful enough for us to jettison the existing concept? And again, we look at statistical significance also from the perspective of saying that the result the researcher is able to find out is not actually due to chance, or it's a real effect. So, by definition, statistical significance is actually designed to indicate whether a result obtained by a researcher is likely due to chance or a real effect. Now, it has its common threshold as 0.05, and that is what we refer to as p-value. When you have the result obtained that is below this particular range, what it implies is that the probability that the researcher's results or consider a meaningful difference could be wrong. The probability is less than 0.05. And that is the threshold, the common threshold we set in research. Now, it helps us to validate the hypothesis of the research at the end of the day. And again, this threshold is important to ensure that our decision on the data is not subject to personal sentiment. It is not subjective, rather it is objective. So this is the concept of statistical theory. Theory is being applied to tell when a difference is considered meaningful. In other words, significant. And that is where statistical significance comes in. Now, essentially, when we assess differences in statistics, the difference could be in terms of category. We want to establish the magnitude of difference, maybe between two categories, say gender, or maybe a group. It could be in terms of lifestyle between two groups. And sometimes it could be a difference between means. Maybe we gather information on height of a data set, the height of another data set, and then we want to find the mean of each data set and compare the two mean. And then we are going to have a difference. Now, the goal is to know if this difference is sufficient to consider it actionable or significant. In another word, of course, it could also affect proportion in terms of rate, ratio, and fraction. Now, if you look at the slides, you have the memory score between young adult and old adult. Now, obviously, when looking at this graph, we can see that the memory score for the young adult is higher than that of the old adult. But this difference we can see here, if we are to make it a subjective decision, based on subjective decision, we can say the difference is considerably okay. But the question again is, subjectivity is bound to differ among different individuals. That is why in statistics, we talk of objective approach to deciding a difference. So the question is, this difference, is it significant enough to consider that the young adult has a better memory, than the old adult? Let's have another example. Now you see, again here we have the bar chart showing different varying percentage, 23% and 29%. Of course, that's a difference. But the question is, how meaningful is the difference? So in a situation whereby the difference is statistically not considered meaningful, we say the difference is not statistically significant. But in the second scenario, where you have 23% bar chart and 32% bar chart, now when we subject to statistical theory and we figured out that the difference is meaningful, then we say it is statistically significant. So we can begin to appreciate that statistical significance tries to measure the difference based on statistical theory and establish a borderline by which we can consider a difference to be meaningful or significant. The same we can say the difference between women and men as we have it on this slide. Okay, physically looking, we can see there's a difference based on the curve. But the question is this difference actionable? Is it meaningful? Is it worth making an intervention? And that is where the concept of statistical significance comes in. Now, let's look at the different ways we can measure statistical significance. There are several ways. The first one is the p-value approach. Now, what is p-value? P-value is actually defined as the probability of obtaining the result, our observed result, or more extreme one, assuming that our null hypothesis is actually true. So when we say a p-value is less than 0.05, we are simply saying that the probability of being wrong is that low. That is less than 0.05. And of course, before we can consider the result actionable, or a result valid, or a difference significant, the probability of being wrong must be very, very small. So when you look at statistical significance, you look at p-value as a way to measure that significance. Okay, so, and of course, we have the different way we can interpret statistical significance as we have on the slide. P-value less than 0.05 is considered significant. Anything above or equal to 0.05 is considered not significant based on the p-value approach of measuring significance. But it's important to understand that this is actually a limitation. There's a limitation when we use p-value to establish statistical significance because it gives us a binary approach of interpreting results. Anything outside this borderline is either considered significant or not significant. Now, let's look at another approach for measuring statistical significance, and that is the confidence interval approach. Now, the confidence interval is a range of value where our population parameter is likely going to fall within with a degree of certainty. That is what we mean by p-value. And we use p-value a lot in different publications to also establish statistical significance. Now, for a confidence interval that does not include zero, it is considered significant when we are measuring difference. When the difference between variable difference of mean, we say a confidence interval that does not include zero. It means when we have the interval, we check between the interval, do we have zero within this interval? If there is no zero or is not inclusive of zero, it simply means that the difference is significant. Okay, so confidence interval not including zero is considered significant, while confidence interval that includes that include one is also, that is not including one, is also considered significant in the case of ratio. Okay, so the third approach to measuring statistical significance is effect size. What is effect size? Now, it's important to understand that beyond statistical significance, it's important to understand that we also measure the difference, the magnitude of difference in our association. Okay, it's not enough to set a cutoff point. We can measure that particular difference, and there are different approaches for measuring these differences. For example, we have the Cohen-D approach, which talk about mean difference, the Pearson correlation coefficients. We have the odds ratio or the risk ratio, if you are talking about maybe case control study or cohort study. Now, it is important to understand that either we are using p-value, or we are using confidence interval, or we are using effect size. These concepts are meant to complement one another, and essentially, the effect size, the confidence interval are designed to complement the p-value. Now, the fourth approach in measuring statistical significance is our Bayesian method. The Bayesian method tries to compare evidence for one hypothesis over the other hypothesis. You see, generally in statistics, our claim, which is the null hypothesis, is what we are trying to establish, whether to reject or to accept. But in the Bayesian approach, we are not just interested in establishing the validity of the null hypothesis. We also want to establish the validity of the alternative hypothesis. So we compare evidence for one hypothesis over the other hypothesis. And of course, we also look at the probability a hypothesis is true of a given data. Okay? And the third is that it provides a direct probability of hypothesis being true, a direct probability. So we are looking at both hypotheses this time around as against looking at just one of the hypotheses. Now, the fifth category are the different alternative tests we can also use for statistical significance. Number one is the permutation test, which involves sampling our data to estimate significance. We can also use bootstrapping. Bootstrapping involves repeated sampling of our population to establish our confidence interval. While of course we can also have the first discovery rate, and this one tries to adjust for multiple comparison. An example is the Benjamin pushback. Okay, so these are different alternatives for establishing statistical significance. Now, in summary, it's important to look at the best practice when we conduct statistical analysis. What is actually the best practice? Number one, we use p-value with confidence interval and also effect size. It's important we use them to complement one another. But there are situations whereby we may have to consider the Bayesian approach, more important when we are dealing with a nuanced inference. A nuanced inference is a sort of inference that takes beyond p-value approach in considering statistical significance. And of course, it is important we conduct multiple tests to establish statistical significance. And of course, we also focus on practical Practical significance is important. That is the end point of statistical significance. Something may be statistically significant, it may not be practically significant. Practical significance talks about the application, the real life application of our research finding. So that is the work we're going to take on statistical research this moment. You can join me again in my next video as I present to you very insightful video that will help you to navigate your research journey. Again, my name is Dr. Felix Ayedele Oyeleye. Bye for now.